Hello, everybody. We're going to be getting started in 1 minute, and then we'll start working our way through the presentation. So we'll give everybody a chance to kind of get caught up a little bit, get online, get the screens all set up. Don't have to worry about muting any microphones because this is going one way, but we do have the chat available through our website. Excuse me, chat available through our website as well as through the YouTube link. So we'll be able to communicate that way. But 1 minute, and we'll get started. Well, thank you very much for tuning in. And it is really, really good to see everybody. I don't know about you folks, but I have had some nasty cabin fever. So it feels really good to reach out. Fist bump to all you out there. We're going to have a great training day today. I want to introduce Katie Smith. She's behind getting the emails out to you folks so you know what the scheduled events are, and just overall a terrific job. So thank you very much, Katie. Appreciate that. Katie's also going to be relaying any of chat messages and throughout the presentation, as they pop up, we're going to address them. We're only looking at 30 minutes, so we want to squeeze as much in as possible. And as you can see, we have a lot to go through. So let me give you an idea of what it is we're trying to accomplish. Our priority or our mission here is to see if we can take our knowledge base and deliver it to you. And the best way to do that is through webinar series. We broke it down into 6 sections. It's built. And in order to do that, we have to walk you through a series of sessions so that you can understand. So why don't document? So the industry basically has 3 class electronic products. What are those? Well, that might be something that has a very limited lifespan and the quality is eh. So for example, that might be a Buzz Lightyear that you purchase through Target. Or hey, better yet, how about the Barbie dream car, right? I know every girl wanted a Barbie dream. In fact, my girls are 30 and they're still questioning me when they're going to get one or not. I don't know. Dedicated service electronics. This is class 2. What does class 2 primarily consist of? Televisions, computer monitors, tablets, refrigerators, and in our case, in the automotive sector and ground vehicles, we could be looking at body control modules, light modules. We could be looking at ECMs, correct? And then third, or class 3, is your high performance harsh environment. And in that, you're looking at very long lifespans and quality that is fail proof. You're looking at on demand requirements. The moment you turn that switch, it better work. And of course, it's all about the uptime, right? In the commercial transportation industry, it's all about uptime. So on the automotive side, some class 3 items: supplemental restraint system, supplemental restraint systems, right? We're starting to automation or autonomous vehicles. All right, so we have industries are on the class 2, class 3 line. Terrific. There's no questions on that. We're going to start plowing now into breaking down a wire assembly. Again, it's about familiarization. It's about terminology. It's about communicating in the same language. So let's take a look at some of the primary ingredients on a wire harness assembly. The first and probably the foremost, which everybody recognizes right away, is wire. Right? Wire comes in a couple of different varieties. Obviously, color. Right? It could look really pretty underneath the hood. Right? We're looking at purples and yellows and greens and pinks and blues, but it goes a little bit deeper than that. The depth starts coming in when we start talking about the wire itself, which could be copper or it can be aluminum. And we'll talk about that in a little bit. But then the next classification or next requirement is the insulation. Insulation is this poly device, nylon device that goes over the conductor, right? This is our insulation. There's SXT insulation. There's GXT. There's TXL. There's TFL. So there's a lot of different groups. Again, on the automotive side and on the commercial, we're typically on the SXT side, GXL primarily for commercial, and then TXL for automotive again. Let me give you a quick breakdown on that. So this wire here is GXL. What qualifies as GXL? It's the wall thickness of the insulation. GXL has very thick wall insulation, which makes it very good for heavy equipment and harsh environments. So you'll find this on a lot of commercial vehicles, GXL. Again, colors, right? Striping. We'll talk a little bit more about marking materials because that is pretty critical too when we start looking at a wire assembly. The TXL line is a little bit more thin wall. Again, high temp environment. So when they think about using TXL, they're starting to think about space, right? It does handle temperatures that are very good for, say, engine compartment and then into the interior of the vehicle. So we took a quick look at some GXL, a quick look at some TXL. Let's talk a little bit about TFL because my feeling is you're going to be seeing a little bit more TFL. TFL is basically Teflon. And the Teflon has a great endurance record, right? And it's very good at dispersing hydraulic fluids, fuel, other, especially harsh environments. The engine compartment could be one of those. And this lifespan is just incredible, incredible. The addition to that is that you get this very small gauged wire. And I'm not going to ask Katie to zoom in quite yet because it could probably play havoc with your screen, but you can get an idea of where we're at here. Just if you look at a quick view, a TXL wire versus a Teflon or TFL, this is about 22 gauge. This is about 16 gauge. Now, you're going to be seeing more of this 22 gauge without a doubt, and I'll demonstrate that as we continue through these sessions. I'll put this away, and we'll look at some additional wire, and then we'll talk a little bit about aluminum versus copper. Some additional wire that's out there that you'll see in a bundle, shielded. You're going to see a lot of shielded wiring. And in our later sessions, I believe it's 5 or 6, we're going to great detail about shielded cabling and where you'll find it, how it's being used. Is it repairable? Is it replaceable? What can we do with shielded cable? And again, an explanation of what a shielded cable is, I'm going to give it to you in a nutshell. Shielded cable is designed to collect EMF, right? That's the electromagnetic field that gets generated around this wire when I start passing current through it, which is fine. When they designed the architecture of the electrical system, they knew that they were going to get EMF on the wires that are passing through your vehicle, but they needed to contain it because you're going to get a lot of interference. And look what's happening today in our vehicles. There's a lot of Wi-Fi, right? And that creates a lot of interference. So to reduce that, they start shielding it, right? They take, in this case, a foil wrap that goes around the wires, and then they create this called drain wire to dissipate the EMF that's collected in the foil to ground. This comes in a couple of different styles, as you could possibly imagine. The number of conductors in a bundle. This could be a 4 wire, could be a 6 wire. Doesn't quite work too well with like 4 or above, because then you're just kind of compounding the problem of EMF. So they tend to use individual bundles of 4 or 6 at the most. Also, it comes in a braided form. And here's an example of a braided form. Some of the advantages and disadvantages is one, on a braided, you can possibly imagine that's a lot of flexibility there, right? This is very good for areas where you know you're going to get opening and closing, opening and closing. But there's a disadvantage to the opening and the closing. The idea is to capture EMF. Well, if I'm opening and closing this braiding, you can see what happens. It tends to have gaps in it. So those gaps is just a hole for EMF to escape. So foil tends to work well and collect more EMF. But here's the trade-off. Work hardening this tends to be a problem. Right? So again, correct application for the correct location in the environment you're working in really gives you an idea of where they're going to go with a braided versus a foil wrap. But we're going to talk about this in much more detail. I want to talk about aluminum versus copper. Nope, I'm going to back up. I want to show some other wire brands, right? So we talked a little bit about EMF, shielding, right? Braided versus foil. Well, there's twisted pair. And again, the purpose is all the same, right? We want to capture EMF. We do not want any of that electromagnetic field interfering with other circuits on our car. So what do? We start canceling it out. We begin twisting these wires so that now your north and south poles are now working in conjunction with each other, which means they're basically canceling out the field of one versus the other, white versus the black sample. So they twist them. And you'll see a lot of this. This is pretty effective, but not as effective as braided or foiled. But you can do both, right? We're talking, right? Now we're really looking at reducing the EMF on those vehicles. And we'll talk more about significant. We also have RF cable. Some of you might notice this. Antenna, right? Maybe your shark fin on your roof terrible, back for that. But we do have RF cable that's out there as well. This one's really going to throw you. This tiring, trouble. So on the Fakra side, they started standard. Why aren't manufacturers just building the same connector? So there's not all these different styles out there that's making it very difficult for us to do our repairs. Well, I think they've been listening, because the series is really going to start taking off. In Europe, it's TE, which is a US-based company, also has a line. Molex, another US-based company, also has a line. And each one of these has serves a different. And at the session 6, which I know for sure, because I was just reviewing that, we go through the entire Fakra series. It gives you an idea of what, again, can be repaired or replaced in the field. And you're going to find this, wow, navigation, telematics, video, audio. So we're going to have to spend some time with this. Another, ribbon, right? So wire comes in 2 forms, basically. Round wire, and ribbon. Ribbon is probably more of a replacement item than it is a repair item. Now, repairs can be limited. That's very possible. Again, depends on the damage, and the parts can be provided. Really helps if, for example, you have an issue in a roof liner, and this is coming through the roof, down the A-pillar, right underneath the dash, all the way across the dash to another module. Yeah, that could be a problem. Floor, you have to rip the whole floor up to replace the ribbon cable. Yeah, again, another problem. But Keep it in mind, there are some replacements available for this, and we'll touch on that again. And that, I believe, is session three. I'm getting pretty good at remembering these. It's session three, where we start talking about the repair and replacement of components. What is repairable and what isn't? So, quick pick. Oh, Katie's messaging me. Yeah, Katie.
We have someone wondering if this will be available on YouTube afterwards.
Yes, yes, very good question. It will. After this live session, it's going to be recorded and then it'll be uploaded to YouTube. Thank you very much. Appreciate that. I forgot to mention that at the beginning, but yes, all six series will be uploaded. I wanted to talk about copper and I wanted to take a close look at the aluminum. So we have two material types now that we could discuss, right? Aluminum versus copper. Alert, alert, alert. You cannot solder these together. You're going to get dissimilar metal corrosion very shortly. So the idea, you can repair this or splice them. And again, this is something we'll cover under repair and replacement, but the technique is a little bit different. And we'll talk about that. Some advantages and disadvantages. Well, advantage here, it's lighter, a little bit more cost effective. However, disadvantage, you need more of it. Aluminum isn't as conductive as copper. So there is definitely a trade-off here. The other disadvantage, this is very susceptible to corrosion. So you will not find it in the engine compartment, at least not yet. You're going to find it maybe in large battery cable, which I've seen a lot of, but not your typical sensor, power, ground circuits. For that, we're still relying on the copper. You will find this is what they call the sweet spots, right? You're going to find this inside the car where they know they have a cost advantage to using it. Wire. And wow, we can continue on that path for at least another 15 minutes, but don't get me started. For me, this is my livelihood and I love talking about it. But let's continue on. I want to talk about connectors, right? Because connectors are yet another key element to the wire harness assembly. And let me give you an idea of what's happening. So a connector manufacturer builds a family, right? And once they build that family, and trust me, there's a lot of engineering that goes into this, a lot of tooling that goes into it. So cost, yeah, the explanation for it. And when they design a family, they want to get as much use as they can out of it. So in order to do so, they start keying it. And what do I mean by keying? Well, we'll see if we can get Katie to zoom in a little bit here. Let me know when you're uptight, Katie. So on the keying side, you'll notice first a color differential, black versus gray. You'll also notice, I have to tilt it up so I can see it, that some of the keys are, for example, at a 5 o'clock position versus a 3 o'clock position. What we're doing there is eliminating a possibility of swapping the connector into the wrong sensor. So they key it. Now this one is kind of a little bit on the obvious side, again, because of the color differential. But let's look at something that's not color differentiated. This could be a real nightmare. Here you have two housings that look very similar to each other, and yet the keying is slightly different. Very helpful though, because it's so easy to have these two sensors side by side, and it's very possible, and be able to swap them. So keying is key. And when we look at connector housings, we like to see photos of the front of this. And now you know why, because we need to see the keying. These subtle differences will just drive you crazy. This is our business, and they're still creating headaches for us. But every time we get a request for housing, we learn and we know what to do with it. Let's look at the commercial line a little bit, right? The commercial line likes using these Canon plugs, or sometimes or Deutsch connectors, which typically use round circular style contacts or uh, um, open barrel terminals. This is another type of commercial grade connector housing. This is a Deutsch series, and these are really watertight. This is a great design feature here. Even when I plug these two together and I snap fit them, they are hard to separate. But at some point, if I could bring this to my ear, you could hear the suction on these things. That's how tight it is. But again, commercial grade, right? That's a lot of environment. When they're designing this type of connector style, they're thinking about commercial vehicles going up to 1,000,000 miles. So now you understand the necessity for class 3 wire assembly on the commercial side. We're talking about reducing any type of downtime. It cannot be tolerated. So again, commercial uses a heavier grade type of connector housing. Let's break into some more anatomy. Let's look at a connector and let's get an idea and dig in a little bit into this housing. So this is a connector, and the connector has what we like to call a secondary or a terminal positive assurance, a TPA clip, right? The TPA is going to hold down a locking tab that helps the connector or terminal seat itself inside the housing. I'm going to pull that out for you, give you an idea of what that looks like. So I'm going to use my extraction tool. I'm going to get in there and lift it out. And now I have access to the terminal face, right? The front of the connector. I'm going to put my TPA away. And next, I'm going to go after a terminal. Now in this terminal, there is a clip that's seated at the top of this housing. You need to lift the terminal clip and pop out the terminal. I'm going to show you an example of a terminal a little bit larger for the sake of the presentation because it's difficult to see the finite details in this terminal. But one thing I want to point out before I move on to the one that I have for this demonstration, I want you to listen to something. I'm going to put this terminal back in and I'm going to get it close to my earpiece as possible. Did you hear that click? That click is a standard requirement for every connector. Anybody doing a repair, if they're feeding a terminal into a housing, the audible click is their number one inspection tool for quality control when they're replacing a housing. The click. Let's look a little bit deeper at the terminal, give you an idea of what's going on here. When it comes to the terminal, everything comes down to the crimp. This crimp is the lifeblood of that circuit, of the wire harness assembly. The standards necessary to hit this are very strict. Tooling and the correct tooling is very important. Let's break down some of the elements of this terminal. And I'm going to use our cheat sheet here, give you an idea what's going on. So if we look at this terminal, it's going to have a couple of key elements I want to point out. One is this area here. This is called your insulation crimp area. And then this area here, or here, is your conductor crimp area. These two are pretty essential, right? The conductor crimp is everything to this terminal configuration. What makes a good terminal crimp? The crimp height. When we look at the crimp height, we're looking at it from a side view, and we're measuring from the top surface to the lower surface. Now, there are go, no-go gauges that you can use in the field to make sure you get this crimp height every time. You can carry a micrometer with you as well, but a pull test is, again, that first indication that you have a good crimp. And we'll show you a factory pull test later on in the sessions so you can get an idea of the control measures behind all that. The terminal, uncrimped, looks like this. What is this? That is what we call an in on a stamped and formed terminal for you. so you can get an idea of what we're looking at. And I'll explain it while Katie demonstrates it. So the stamped and formed starts out through the dies. It's going to stamp it and form it, stamp it and form. After it's completed its cycle of stamping and forming, you're going to get this strip. You're going to get a terminal strip, and these terminal strips get fed through an automated process, barrel style terminal, or stamped and formed. Stamped and formed comes in a couple of different varieties. You have terminals. So again, thousands, thousands of terminals out there. Thousands of terminals matching up to thousands of connectors. So again, identification of these items is extremely, extremely essential. This terminal will not fit into every other flag terminal. It's just not possible. So you have to know what goes where, what fits where. We also have terminal lugs, and I'm sure most of you recognize that. That's something that could probably plug onto your go onto your battery, right? And that is some pretty big gauge stuff right there. I would not recommend using this in the field. Uh, the need for good and firm contact on a cable that size is pretty essential. You're passing a lot of current through it, and it needs every bit of surface area it can get. So we'll think about that and talk about it a little bit later in the sessions on what we could do for our customer in the field. One more, take a peek at, and I'm going to have Katie again flash this on the screen for you, is a contact. The contact I use a lot lately in the commercial side. The automotive side is picking up on some of the contacts. You'll find that on circuit boards. But let's take a look at the anatomy of that. It's a little bit easier on the crimp side. You don't have to worry about crimp height so much. What you have to be concerned with is the dimpling. Right? Where are the dimples going when you crimp your wire or conductor to the barrel? Also, there's an inspection hole here for you to make sure that you have the correct depth when you go to insert the wire. Also, color coding. This color code, you decipher it, can get you into the correct terminal for that application. A lot of these are military spec. So these are standardized very well, actually, which makes it very convenient. Thus, the color marking helps tremendously. I want to talk a little bit about some inspection methodology. What do I mean by that? I mean that you need to know best practices going into the inspection of a wire harness assembly. And I'm going to talk on it very briefly because we do go into it in more detail in the repair and replacement section. But some things to keep in mind. It's probably going to be essential that the technicians have some type of magnifying glass available to them. And I'll give you an example why. We received this assembly from a customer that was removing harness assembly from the vehicle. And when they were removing it, they accidentally cut the bundle. And I know it's going to be hard to zoom in on this, but to give you an idea of the nick, it's pretty minute, right? But boy, has it opened a can of worms here. And since it's such a small gauged wire, the customer didn't feel comfortable crimping on a new lead or splicing it. It gets kind of tricky when we get into smaller gauge wires when it comes to splicing. But again, we're going to talk about that. What can we do? It's going to be coming up. It's going to be coming at you. One other thing to consider on inspection, again, more detail on all that, is your lighting. Let's think about natural lighting. Boy, if you could be outside every time you need to inspect a wire assembly, you're in ideal territory. The next best thing is an incandescent flashlight, not LED. There's an issue with LED. LED sharpness and its light that it doesn't cast a shadow very well. The light actually cuts an edge around the image so that you can't see if there's a nick or a mar on it. So LED lights are not highly recommended for inspection devices, especially on small items. So another item to keep in mind. I want to stay on track, and I want to summarize. We went through all of the various elements of a wire harness assembly, and all these little pieces sum up, right? What do they sum up to? This. Think about what we just spoke about. All those little pieces. They don't look like much, do they? They don't add up to a hill of beans, as they would say. But look at the outcome. This is a very complex piece of manufacturing right here. A lot goes into this. That is why this assembly is about $4,700. It is big, it's complex, it required a lot of engineering. The architecture of the electrical system is the most expensive part of designing an automobile. And now you get an idea why. So thank you again for tuning in. Really appreciate it. And good to see everybody. Good to see you. Stay safe, be healthy. I'll see you on Monday at 9:30. Thank you.